Yo, what's up, guys? Episode 175, dude. We're so close to 200. We're gonna do a couple problems, probably one problem actually. Um, it's getting a little late, dude. Past my bedtime type shit. So probably go ahead and look at one problem. So actually, let's take a look at the problem of the day. Is my screen sharing, Ethan? Oh no. Yeah.
Yeah, I can see yeah.
Let's have a look at what the problem of the day is, dude. Should we take a look at this, dude? 88%, dude. It's probably easy,
Let's
bro. Let's take a look at this. It's my GitHub, dude. Whoops. That over here. Okay. Take a look at this. 22044. Let me open this on my phone. Dude, fuck. I gotta call my parents too, dude. Llama, dude. What's up, bro? Sup? Good to see you, dude. Appreciate you joining back, bro. Gotta fucking turn on my brightness a little bit on my phone. Okay, let's take a look at this problem. So we're given an array. Integer array nums, find the maximum possible bitwise OR of a subset of nums, and return the number of different non-empty subsets with a maximum bitwise OR. An array A is a subset of an array B if A can be obtained from B, deleting some possibly zero elements of B. Two subsets are considered different if the indices of the elements are chosen are different. Okay. I don't really know. I have to kind of think about this. So what are we returning here? We're returning an integer. Got a count here. Maximum possible bitwise OR of a subset is 3. There are two subsets with a bitwise OR of 3. So is this bitwise OR to itself, Ethan? You think, right?
Yeah, I think I think so.
And then bitwise OR 3 and 1. I didn't even know what a bitwise OR would be on like an integer like 3 and 1. Oh, binary.
Yeah.
Right? Oh my gosh, dude.
It's like it's just taking the binary representation of the number and ORing it, I think. So the maximum possible bit OR of a subset is
2044.
Okay, so it's trying to find, because like if you OR 3 in itself, you get 3, and if you OR 3 and 1, you also get 3. So
right, if we write the binary representation, let's build this up here just to make sure we understand what's going on here. So we're given one subset here, right? So we look at itself. So we get the binary representation of 3, which is what? 1, 1, 0, right? Oh, right. We OR this together, and OR would be, the same thing, right? 1, 1, 0, right?
Yeah.
So this would be 3 and 3, right? And then we look at our next subset, which would be 3 and 1, which would be 0, 1, 1, 0, 0, 1. Oh yeah, so then it would be the same, right? We would go 1, 1, 0, right? Or if this is 1 as well, so it would be 3, 2. Okay, so there are two subsets with a bitwise OR of 3. The maximum possible bitwise OR of a subset is 3. Then we're returning 2, because there's 2 of them. So it's like a count sort of thing. Or
because we're trying to count how many subsets within the array have the maximum bit OR of a of the subset. So like in this case, like 3 in itself is the highest, and so is 3 and 1.
Right, let's take a look at this one. Something a little different, right? We can take a look at this one. Let's get the nums here. See, to make sure that we're thinking about this right. I feel like when you look at this one here. Okay, so we're given every single... Oh shit, this will take us a while to do everything, right? So this subset we OR in it. So pretty much when you OR yourself, you're always going to get the same number, right?
Yeah.
So I guess we can limit that out, right? So we have 3. I guess we can have some sort of like, probably have some sort of hash map here, right? To probably solve this problem.
Right? Yeah.
Like mapping like the key, which is like, the value that we have, right, to our count, right, of some sort. So in this case here, we have 3, 1 here. We bitwise all this, 3 and 2. So that would be 0, 1, 1, 0, 0, 1, and we would get 0, 1, 1. Oh, no, sorry, 2 would be this one. Whoops. So that would be 3 as well. So now our 3 goes to 2, right? The maximum possible bitwise OR of a subset is 7. There are 6 subsets with a bitwise OR of 7.
Yeah, because like if you OR 3 and 5 together, for example, like if you were to write it out, it'd be like 1, 0, 1 or 1, 1, 0.
Oh shit, yeah, and then we're bitwise ORing fucking 3 numbers together, dude. Oh my god, dude.
Yeah, because then you get like add 2 to 5 and get 7. And then in this case, it'd be the same.
Okay. Array backtracking, bit enumeration. Backtracking problem. So backtracking to get the subsets, right? I would assume.
Yeah, probably. What are the constraints? Okay, so I mean, you could use like an O of n or O of n squared solution here, I think, right? Because like length is only 16.
Yeah.
So like,
wouldn't backtracking be slower than n squared, right? No, it would be the same.
It's still an O of n squared solution, I believe.
Okay.
Backtracking is.
Okay.
So what are you thinking?
I mean, we probably could. I got to. I have to set up my. My thinger. Let's take a look here. Let's open this up. It's 2044. Boop, boop, boop. Okay. Trying to think here. Well. I'm still thinking a hash map, maybe. Or do you think there's a better way to do it, to store all the values here? Or is there probably a better way to store the values, you think?
Well, so I don't know. I mean, like with a backtracking solution, like as we're creating the subsets, you could like be calculating the bitwise OR, right? And yeah, I guess like you could track like how many of them. Yeah, like a hash map would work because like what are you storing? So what are you thinking of storing in the hash map?
like the key being the answer to the bitwise OR, and then the value being like the count of how many times we've seen that value.
Yeah, that's a good idea.
But we could, you're saying use an n squared solution like this, like finding all our subsets using a double for loop, right? Having I here and then doing all our subsets like this, right?
Yeah, I mean that you could. Either way, it'd be like almost the same. Like you're pretty comfortable with backtracking there, right?
I am, yeah. I'd have to probably have a look at backtracking in C++. I mean, I'm pretty familiar with it, but sometimes I get a little rusty. I haven't done a backtracking part in a while. But yeah, I am.
Okay. Yeah, I mean, whichever solution is more intuitive to you, I guess. Like, if you wanted to try backtracking, then go for it. You could also go for like the iterative solution.
Yeah.
Yeah, ultimately, you just need to like get all of the subsets, and then compute their bitwise OR and store it and increase the count.
Yeah. Let me just.
Like, and I guess you could like, I don't know, like you could maybe try to be smart about things because like let me see something. Yeah, like it just wants like the unique subsets, right? So it's not like you could do 3 5 and 5 3, right? An example 2. Like it's just the 3 5.
Sorry, what are you talking about? Sorry, what are we referring to? This here, 3 5.
Yeah. So like when we're going and we're creating all the subsets, right? Like we couldn't have like duplicate subsets is the thing. Like we couldn't have like 3 5 be a subset and then also be 5 3 as a subset because we get like twice as many
Right,
scores.
so we have to check for duplicates. That's what you're saying.
Yeah.
Okay.
Or just like in the way that you implement it. Like I guess like if you were to use the iterative solution, that would be just a way to do like a linear pass through it.
You might have to help me think about this in terms of this, right? So we would have let's try a backtracking solution because I haven't done any backtracking in C++, so it's been a little while.
Yeah.
Well, honestly, I've never done it, so let's. It's been a little while. I've never done it. So we'd have a backtracking function, probably a void function, right? We would want to pass in our probably a vector, right? The vector that we're operating on would be a start. Probably want to count, or no, we were doing it with a hash map, so I guess actually we'll just leave this for now. What do we want to do, right? We probably want to call that function, right? Backtrack with whatever we want to put in it. So let's think about what we want, right? We probably want a nums. We want we need an I, right? Whatever our I that we're looking at is. Trying to think. And a J, right? Oh,
So yeah, you could do that. Yeah. So what you're gonna try to like do a sliding like I guess it's not. Is it a sliding window? Is that what it is, or is it just 2 pointers?
No, it's not really. No, it's not a sliding window. It's hang on. I'm trying to think. Trying to think exactly how I think about this, right? So we have our backtracking function, right? We have our I, right? We have our array that we're operating on, right? Some values. We have an I being our index, right? That we're looking at, the index value that we're looking at, but we're comparing these values, right? So I feel like we would need some sort of J to compare at, right? In our backtracking function, right? Am I thinking about that right? Or is that incorrect?
Yeah, I think you're thinking about it right. What's the overall? So that's like the overall array, right? Like that's the vector of nums, the 2, 3.
Yeah. Yeah. I just made a small
Okay.
one.
So yeah, like the subsets here would be like 2, 2, 3, and 3.
Yeah, right. But like we wouldn't be able to increment our index, right? Or we wouldn't be able to compare because we need a J to compare to the other value, right?
Yeah. So yeah, you need the 2 pointers here.
Yeah. Okay.
And also, wasn't it saying like, so a subset, right, is like where you can just remove a number? Is that what it's saying? Because like the subset doesn't have to be like next to each other.
I don't think they have to
It's
be
like,
next to each other. No, I think they can be like, yeah, like 3, 3, 2, 3, 1, 3, 5.
yeah.
I think they all have to be in a row. Actually, yeah, I think that's what. Yeah, like they got to be all be next to each other. Subset of like numbers that are all.
No, because like if you scroll down, right, it's like the second one is removing the 2,
Oh yeah,
like
there's
on
2,
the
5 here.
yeah, and then like the second one is like 3, 1, 5, so it just removed the 2. So like you could have like some sort of index going through, and like if you're on 3, you could try to create all subsets when removing 3 or something. I don't know. Like that could be one way to look at it. That just add complication though, because it's not just like next to each other. So like the 2
Yeah, I'm
pointers.
not sure to kind of how to handle that actually. I thought they were all next to each other to be honest. Um. Hmm.
You want to play some music?
Oh yeah, yeah. So, what is it called? Man, I'm blanking out. What is it called? Lo-fi, dude. Oh my gosh, lo-fi. No copyright.
This was me before I got an AI employee. I was unmotivated, overworked, and...
Bro,
What?
what an ad. That ad was funny.
Oh, hello there. EG. What's up, dude? Welcome to the stream, bro. Playing some lo-fi and doing leak code.
That's the mood.
I like this one better than the one I usually play, actually. This one's some relaxing piano music.
Yeah. Yeah, I like to listen to classical music, honestly. Like when I'm just listening.
Yeah, man. I am not sure kind of how to think about this. That does add complexity. Maybe.
So like one idea, right, is like go through and for example, like, okay, just look at example 3, right?
Yeah.
You could say like, okay, I'm going to go through and I'm going to like, let's say my pointer, right? Like I is on 2, for example, right? You could say, I'm going to go through and I'm going to create all subsets that include that include 2, and then all of them that don't include 2. So you could create, you know, like Or actually, just to make it easier, just all of them that don't include 2. So you can make like 315, 31, 35, 15, right? Like all the ones that just don't have 2. That's one way that you could do it. I don't know if that's the best way to do it, but I don't know. There's probably like, do you recognize any of the topics or categories from like any of the other problems that you solved?
What do you mean by that? Like, are you talking about this or?
Yeah. Like, why do you see how backtracking could fit in here? Or just not really.
No, yeah, I see how backtracking could fit in here, like to find the subsets. Yeah.
Okay.
Bit manipulation. I mean, I assume it's because we're like, you know, ORing 2 things together. That's why it's been manipulation. Nothing much. Has been a pleasant morning so far. Oh, leak code. I've never done those. Probably might have to start later. Yeah, bro, they're pretty AIDS, dude. But they're fun. Okay, so you're saying, so if our I is here, we have a J here, probably that starts from the beginning and takes a subset.
Yeah, like, so it takes itself.
Right here, J moves here now. So that if it's equal to I, we don't want that. But how would we remove the value? Like, that's what I'm confused about. Like, if we're keeping our I here, how are we able to take the subset? Oh, we add, right?
Yeah.
We start here at J.
Like, you're just creating multiple subsets. You're like, I want, you know, 3, 3, 1, 3, 1, 5, for example. And like, you could just you could change which number you're starting on, like for each subset. I mean, that's probably not a very efficient way to do it, but
yeah.
What's the name of this problem? Or the number?
2044. Yeah, I understand, I think, what you're saying, but I'm having trouble thinking about how I would program that logically. I think that's what I'm struggling with right now, but
let's see. Do you think you should start it in Python first? Like, would you have a better idea there, or just like in general?
Just in general, to be honest.
Okay. I wonder if there are any like tricks to this problem, like some sort of way to easily get all of the. Because like, have you ever, like, really what I was trying to ask earlier is like, have you ever done a problem where you had to get all of the subsets like this before, or have they usually just been like next to each
but
other?
they've always been in the one that there's a subsets problem, but they were next to each other. So I've never done one where like we're not including the I here, so I'm a little lost trying to think about it.
I see.
I think it's mainly just the backtracking. I think that I'm sure maybe I should do it iteratively. Maybe.
Yeah, I think that would be easier to think about personally. One thing though, like just to get the maximum, right, is like when you think about it, the bitwise OR of all of the numbers in the original like vector of nums is the maximum, right? So like 3 or 2 or 1 or 5 is equal to 7.
Okay.
Right, because like it says an array is a subset if A can be obtained from B by deleting some or possibly 0 elements of B. So like the original nums array is valid. Like that's a valid subset based on their description.
Yeah, I'm gonna search up this fucking problem really quickly. It was in a weekly contest, so I'm curious to see kind of what it was rated. Cause I feel like this is kind of tough. I'm just curious. What is this? 2044. 1567. Okay.
This message is brought to you by Apple Card. Get 3% daily cash back when you buy an iPhone 16 with your Apple Card at Apple. Subject to credit approval. Apple Card issued
Oh, it's
by
all
Goldman
it's
Sachs
all
Bank
about.
USA,
Oh,
Salt Lake
it's
City
about
branch.
all
Terms and
possible
more at
subsets.
applecard.com.
Yeah, dude. It's kind of frustrating. Definitely struggle with it though. Let me skip this ad really quickly. There we go. We're good. Maybe we can get rid of the spec tracking function. Less than size. Possible size.
So like we're gonna like the outer loop is gonna have to go from like 2 to the power of n minus 1.
2 to the power of n minus 1.
That's like how many possible subsets we would have, like without like the minus 1 because we exclude the empty subset.
Okay. Okay.
So you could say like I is less than 1 a bit shift left in.
Here in this inside the for loop here.
Yeah, that's how you could represent 2 to the power of n.
Right, because we have reason why we're doing this is because we have 2 to the power of n possible subsets, right? That's what you're saying?
Yeah,
Okay. So
because like you're gonna do a double for loop here, right?
yeah. So
Yeah. And like in I guess is like the nums dot size, right? You want to shift it left, yeah, and then you can start I at 1.
should this
we
be
don't...
2 to the power? No, wait, no, 2 is num size. No, wait, what?
Yeah, no, it's 1. So like we're taking 1 and we're shifting it over like in binary form, like to the left.
Okay.
By num size, and num size could only be 16 at most, so it would be like 65,000.
I'm just gonna wrap this just because just so I can see it better. Like I is less than 1 divided 1.
And then you could start
could you jump on the stream and do the bit shift thing for me again, just on stream, just so I can visually see it?
Yeah, sure. So like if I did 1 shifted over by 5, right? Like 1 looks like this in binary, right?
Yeah.
So whenever I shift it over by 5, I'm literally taking this 1 and I'm going like over 1, 2, 3, 4, 5 places, and I'm putting it like here.
Right. Okay.
So then this number becomes, like this is 1, 2, 4, 8, 16, 32, right? So that 1, 2, 4, 8, 16. So it's 16.
Yeah, that represents the amount of possible subsets, right? Playlist.
Right. And then this is 2 to the power of 5.
Yeah. Okay. Sounds good. That makes sense. Okay. Ahmed, playlist. What does that mean, bro? I don't know what you mean by that, dude.
He likes your music.
Oh, music. It's dude. It's lo-fi background, no copyright, dude. Chill aesthetic, bro. Yeah, just some lo-fi, dude, on the internet. Fucking piano and shit, dude. Music. Yeah, just some piano stuff, dude. Some relaxing piano stuff.
Like one idea actually is instead of instead of building each subset and then going through them, like you could just go through them. And then this is kind of what I was trying to say earlier. Like instead of like storing each subset in a map, right? Like with the count and things like that.
Yeah.
Like while you're building the subset, you can just like keep some sort of so to begin with, like before I go into that, above this, you can just go through all of the numbers once and like get their OR value, right? So like go like above all of this on line 21.
Yeah.
And you can keep some sort of like int max OR value. Yeah. And then you could go just, you know, for int in nums, like right under the max OR.
Okay, here.
Yeah.
What do you
You
want
can
me to
just
type?
say like for int like num in nums. Like do a range based for loop in C++. Yeah. And then you could just say max or equals num.
Max or
So then do a pipe and equal sign.
pipe. Like this?
And then num. Yeah.
That's a thing? Oh shit, okay.
Yeah. So then like
Okay.
so like this, like we've already gotten our maximum OR value to compare everything else against. Like we don't have to like, because like the key insight here, right, is like the nums array that's passed in is already a subset of itself.
Right, okay.
So the maximum value that we could get is all of them OR'd together, because OR doesn't like decrease anything. It just increases or stays the same whenever you do an OR on something.
You know how we all have that one friend we go to with all our
Okay,
questions?
yeah.
Well, meet Experian. Your BA
Yeah, okay, I understand.
big
Yeah,
financial
that makes sense.
Experian is gonna be your
I guess I don't really think about it like that because I don't,
Just download the Experian
you know, I'm not
app and
really
get started
super,
for free.
you know, as good as you with bit manipulation, and I don't know about that, so okay.
Yeah, it just comes with, you know, you'll practice and stuff. But then
So
like
you're
now
saying here that like as we compare along our nums array, our max num can only go higher when we OR it with other things, right? It can never go lower.
right, it can only stay the same or go higher.
Right.
So like 0 OR'd with anything but 0 will go higher.
Okay, so this gets our max num. And what are you saying that we just if we have our max num here if we have our max num here, then we can just look for that number when we're ORing on our subsets? Is that what you're saying? For this, looking for this max OR?
Yeah, exactly. So like on this outer for loop, like right here, like before we go into the second for loop, you can keep some sort of int that's like the score of the current subsets or values.
Yes, we can call it cur OR. And then what we loop, right?
Yeah, and then this time you'd go through like, you know, 0 to
The
n.
size, right? Size
Yeah.
of nums. J++. And then what we want to OR with our current run, right? We do cur OR.
So, so first you need to check like if so again, like we're trying to build all the permutations, I guess, for like the iteration. So like you'd have to check like if the jth element is already in the subset, right?
Okay. In what subset though? I thought we're only keeping track of like
Man,
our
let me see if
current
I can-
OR.
I don't know how to type. Hold on, I need to do some research. I don't want to just guess. Okay, yeah. So first of all, you probably want to start like just because we don't want the empty subset. Start like I at 1. And then like you can do an if check inside of the second for loop that checks like if I
Yeah.
and 1 shifted over by j in parentheses. And then you'd check like just if that does not equal 0. Then we can like or nums j into the subset.
Hold on. So what? Is this what you're saying?
Yeah.
Wow, bro, this is an interesting way to think about it. I would have never got this. I don't.
Well, bro,
I struggle. I struggle with bit manipulation problems, dude. Like, I would never like think about this. You know, like this is really interesting way to think about it. Is this Java? No, dude. This is C++.
Yeah, definitely not Java. And then like under the inner for loop, right? You just check like, hey, is our subset or score equal to like the maximum? Then you just increase the overall count.
Okay, if our yeah, if our cur or is equal to max or
That's that is not C++.
fuck, dude, this is Python. Fuck. Cur or is equal to max or
Yeah, then plus score. There we go. That should be it.
Hey bro, what's your project? This is not a project, bro. I know it kind of looks like it probably because I'm using Visual Studio, but I'm not actually doing a project. I'm doing leak code, so. Debug session failed. Vector subscript out of range.
Hit retry. Go and then go into the edit. Oh wait, you need to run the debugger.
Oh, I need to put a breakpoint, right? Fuck.
Well, it's gonna crash apparently.
Should I just see if it crashes? Step through it and see if it crashes, or
Yeah, you can hit F5.
there you go.
Oh, click retry.
Oh.
So it's saying we're getting an array index out of bounds exception, which is interesting. Oh, you shouldn't have stopped it.
No, my bad. Sorry. Should I just run it again?
Yeah, hit F5. And then just hit F5. And click retry. And then just go back to your code. So where is it? Go to the call stack, like on the right. Double click on the second one. Okay, so we're getting, so J is out of bounds. J is 2. What is nums?
Nums is 2.
Oh, look, okay. You have while I is less than nums.size in the second.
Shit. Okay. Um, 2044.
You gotta hit F5 unless you want to step through it.
I'm not returning. Fuck me, bro. Oh my god. I'll just let it run. Size is 4. Expected to, actual 3, expected to. Pass this one.
Okay, so there's some issues here. Let's try to figure it out.
Should I actually step through it?
Yes, try to step through it now. There's gonna be a lot of iterations, but it couldn't hurt.
Otherwise. Yo, Goku, dude, how are you? I'm good, bro. How are you, dude? Good to see you again, bro. Back at it again, doing this problem, bro. Let's see what our max order is. So our max order is 3 in this case here, right? And, okay, so that's right. So this if statement here, I and 1 bitwise shift J.
Yeah.
What is this exactly doing off the? Again?
So this is just kind of like so okay, so the AND operator, right? Oh wait. I think you have too many ANDs there. I think that's why it's not working. It needs to be a single AND sign.
What? Cause what's a double AND?
That's checking like that's like a logical AND. You know, like Boolean AND.
Okay.
You're trying to do bitwise AND.
Okay.
So this should actually work now. So hit F5. I believe it should just pass. It's still not passing. We have a different, so we're closer. So there's something else wrong
bro.
here.
That's good,
We're
Goku,
passing
dude. I'm happy you're good, dude. You working on
Okay.
anything today? Any projects or anything? Okay. Sorry, what
if you just remove like does not equal 0? It's gonna make less sense, but just remove the not equals 0. Okay, now try to run it, just to see what happens. I want to see if it doesn't work again.
Uh,
You can just say F5.
there we go.
There we go. Okay, that's what it was.
Could you explain me how you kind of came up with this right here?
Yeah, well, I mean,
This if statement?
yeah, I just remember it from a while ago, and I had to look it back up again. But it's basically what we're doing here is okay. So like all the possible subsets of like anything, any array is like 2 to the power of the size of the array.
Right.
So that's like the outer loop, right? So we're taking from 1 all the way to that number, right? Because that's like essentially how many subsets that we have. And what we're doing is we're essentially trying to get, like, if you look at my share screen here, so like
Still
let's say that
learning
we just
Dom. That's good, Goku. Let's go, dude. Sounds fun, bro. Sorry, man. You can keep going.
no worries. Let's say we had like 3, 1, 5.
Yeah.
Okay, so what's gonna happen here, essentially, like what we're trying to do is we're basically making like a table where we have like our actual like num, or in this case, I guess it would be like I, and then we would have our binary right here. I'll just do like bin, and then we have like the subset that it represents. Okay, so as this number increases, like 1, 2, 3, 4, 5, so on and so forth. I guess I'm gonna run out of space here. Let me remove this example.
Get rid of the game, bro.
Yeah, no more pathfinding. Let me make this a bit longer here. Okay, so we go all the way down to like 5, 6, and 7, and then we have 0, 0, 0, and this is why we're starting I at 1, right? Because we don't want the empty subset.
Right.
Okay.
Okay.
And then as soon as, like, what is the binary representation of 1 up to 3 digits?
Ah, that's
0,
the
0,
sound of
1.
someone who's who's misplaced.
Yeah, 0, 0, 1, right?
Debit card.
So then what this is going to do is it's going to take our first index here. So then this represents our subset of 3.
Okay.
And then what is the binary representation of 2? It's 0,
0, 1,
1.
Yep, just a few
So,
taps on his phone and
just
So
curious,
that's gonna
like in this case here, why are we going up to 7?
that's peace of mind from Chase.
Because that is like the maximum number of subsets here.
Okay, right. 2 to the power of n. Right. Okay. Yeah.
Yeah, so 2 to the power of 3 kind of thing. And then, so it's like 8 is the answer. And then 3, right? So it's, when we get to 3, this is when like it becomes probably more obvious what we're actually doing. So 3 is 0, 1, 1, right? And like maybe just so that everyone is can make sense of this, I'll do something like this because my drawings are pretty terrible here. But so this maps to 3, right, as our first subset, and then this one maps to 1, so 1. And then as soon as we do 0, 1, 1, right, our subset becomes what would it be? 3, 1, right?
Yeah.
You see how that works? Because like we're just directly mapping the binary representation of the number to the indexes in this subset here.
Okay. Can you do 3 again? Just like go from 2 to 3 again, just so I can make sure I understood that. Like.
Yeah. So like 3 again in binary is 0 or 0, 1, 1, right?
Yeah.
And then like again, so for 1, this is 1, right? So this is our first index, 1.
Yeah.
Right, and then this represents our second index here. So then whenever we go to 3, we contain both indexes essentially.
Ah. Okay. Yeah. Okay.
Right, and then we can just keep going. And like this way is just it's a way to get all of the representations of our numbers in binary.
Yeah. Okay.
And then we do that check to be sure, like, hey, is like the jth element already, like, is it in the subset, right? So like, for example, if I was equal to 1 and j was equal to 1, or j was equal to 0, right? Then that would work out, because like if I is equal to 1 and j is equal to 0, then what we were doing is we were saying like, hey, is I and 1 shifted over by j, like, is this true essentially, right? Is this a truthy statement? Like what would we have here, right? Like we'd have 0, 0, 1 and 0, 0, 0. So like if we and these together, this would be false, right? Because j is equal to 0. But then as soon as j equals 1, then 1 shifted over by or no, this would and out, to 1. Yeah, because we're skipping 1, or we're skipping 0. And then when we and these together, this gives us the same number, kind of thing.
Yeah. Wow, bro, that's pretty impressive. I would have never thought about it like that, bro. No shot.
Well, yeah, I mean, I definitely had to like look it back up. I didn't remember it offhand, but I just had done this a while ago.
Yeah.
And like it's pretty cool. Like it's a cool trick to kind of learn when you're dealing with binary. I mean, I don't know how useful it actually is like all the time.
No, yeah, I probably
but-
would have just fucking solved it with a hash map. That's interesting though, dude. Step 1, list all non-empty subsets. Step 2, find the maximum or step. Step 3, count how many subsets give or equals max or. Yes, Llama, that is correct, dude. That sounds good. Theodoric says, what do you believe is the hierarchy of industries most desirable that programmers would want to work in? What do you think, Ethan? I have no idea, to be honest. I'd just say whatever you want to do, dude. Whatever makes you happy, but I don't know.
I mean, most desirable is different per person, I guess. Like, if you're trying to get paid the most amount of money, then you could get paid a lot of money being a contractor. Or you could get paid a lot of money, being an entrepreneur or just, like, creating websites for people. But if you want to work on, like, game development or something like that, then maybe taking a pay cut to work on games is something that you'd want to do. Just depends on the person. I don't know. I mean, like most software jobs are very lucrative, so I wouldn't really worry too much about like how much you're gonna get paid. Just kind of try to find what you're interested in, and then work in that specific field.
There you go, bro. That's some good advice right there, bro.
Thank you.
Whatever makes you happy, bro. Whatever makes you happy.
Like if you're just doing software engineering for like the bag, like if you just want to get paid, then you know I'd recommend maybe trying to find something else because like you'll probably get burnt out really quickly.
Yes, sir. Yes, sir.
Are you gonna do one more? Or are you gonna call it?
Let's do one more, bro.
All right.
Because I feel like you carried me on that one, so I feel like we gotta do one more. Let's see. Let me open. I kind of want to do a backtracking problem, bro. Is that cool?
Yeah, sure. I mean, I'm just not, you know, I can't really help too much there. I understand the concept, I think, but
Nah, bro.
you're kind of a pro at those.
You can help in anything, bro. What do you mean, bro? I can't help. That is cap. That is cap. Straight cap.
All right, here. I'm gonna just go grab some water real quick while you load it up. I'll be right back.
Damn, dude. I kind of just want to look at a. Man, am I tripping? How do I? You get to. Here we go. This is what I was looking for. Study plan. Let's take a look at a backtracking problem. I kind of want to do it in C++, dude. They have backtracking on here. They do. Permutations. Let's do classic subsets, dude. Take a look at this. 78 subsets. Classic, top 100 most liked problem. Classic. Let's take a look. Let's fetch. I think it was 78, right? Yep, that should be right. How you still here, Goku? How you learning about the DOM, bro? You following like reading about it, or what do you how you learning it? Do you guys use Linux at all? I dual boot. I use Linux a little bit. Not a professional or anything, but I do use it a little bit. You use Linux, Theodoric, dude? Let me think about this problem in Python first. This might be easier for me to translate C++. Given a visual numbers of unique elements, return all possible subsets. The power set. The solution must not contain duplicate subsets. Return the solution in any order. So what are we given? We're given num 1, 2, 3. Right.
All right, I'm back.
What's up, bro? Yes, Debian stable with micro editor. I have no idea what with a micro editor is, dude. I'm not sure what that is, but that's cool, dude. I use Linux Mint on my other boot, but yeah. Hey, dude, just found your channel. What's up, watching, bro? Thanks for stopping by, bro. Appreciate it, dude. There's a selection of elements, possibly none of the array. So what? We're given 1, 2, 1, 3, 2, 3, 1, 2, 3. Okay. Bro, my eye, dude. Fuck. Dude, I feel like the code for backtracking is on here is probably crazy, bro. For C++. Like,
Yeah, I've never, well, I mean, it's just like a recursion, right?
yeah, I'm
Is
gonna
it
do it in.
or-
I'm gonna do it in Python first. So I'm thinking probably a backtrack, an eye, and a path. A path being maybe like an array of some sort. So the way I'm thinking about it is, if the focus is on C++, then all the jobs are too complicated for new people to get into. How can one break into a field, especially if they enjoy complex projects that CPP brings but also want to earn? That's a question for you, Ethan. You should answer that.
Well, I mean, it really depends on how you like define too complicated, I guess. I mean, like, so like whenever I was 20, I was hired at my current job and I didn't even know C++, and that was like the language that they used, you know, so I just learned it on the spot and then I started programming in it. So, you know, like as long as you just know programming fundamentals and you know operating system fundamentals and like how memory works, you know, and like what you're actually doing, you should be able to pick it up and start working on projects. I mean, like, you know, like there's language specific skills, but then there's also just like understanding programming in general. So it just depends on how you define like complexity, I guess.
There you go.
Like if your goal is to work on complex projects, but you don't know C++, then just work on them in the programming languages that you know. And then, you know, maybe try to learn C++ on the side and then start to do projects in C++. But the experience will transition across languages usually, unless you're going from something like web development to like systems engineering, like as long as you're doing something like Java or something like that.
Theodoric says be a pro and start in C or assembly.
Bro, honestly, I'd recommend that everyone starts in C. I think starting in C is probably like the best possible like choice anyone could ever make.
There you go, dude. Trying to think here. I think we need a result here. Append. One way. Turn the result. Let's call this res. You got this, bro. Thank you, C-Lots. Appreciate that, bro. Thank you. It is getting a little late. Solution must not contain duplicate subsets. Return the solution in any order. We have a backtracking. We want to loop through each value. We have our I. We set our I to where we're at, right? We have our I. We would go path.append. Thumbs I.
Bro, you could use the same trick that we did last time. Low key.
For this one?
I think so.
Yeah, you
I
could.
probably
I
shouldn't.
purposely picked subsets just to. Hello, buddy. Good to see you. Thank you, bro. Good to see you too, bro. And here we can backtrack, right? We go I+1. We pass in our path, and then we want to pop, right? So we would go backtrack. Sorry, no. Path.pop. Have you tried Lovable? A good way to build a website using AI to showcase your resume. Yeah, I mean, I've heard of it. I haven't never tried it.
See, Max is a Chad, and he can just build his website without AI. He's
I'm
React,
Chad, bro.
you know.
I'm like Giga Chad, dude. Did you switch your language again, dude? No, dude. I'm just doing it in Python first, and gonna think about it in C++. I think I'm gonna get fucking cooked on a C++ solution though, but it's all about the learning, I guess. But anyway, let's see what we get here. We backtrack here. We call our res. We need to append, right? So let's. We have to append inside the 4. Yeah. So we're not going to return anything here. We're not appending anything.
Bro, I think this is actually like the solution or the problem I remember that bit manipulation trick from.
Actually,
Yeah.
Python
like,
has a
you know,
bad reputation for performance. Not gonna lie. What industry are you trying to get into? I'm just trying to look for a entry level role in software development.
what?
What's that? Did you have a question?
Why did the guy talk about Python's performance?
He said Python has a bad reputation for performance. Not gonna lie. He deleted it. Oh no, he didn't. He kept it. Simplify is also good for quickly updating CV. Never heard of Simplify though, dude. Name I is not defined. Oh, whoops. Need a 0 here. Numbers not defined. Maybe you want to go for length nums. Maybe we should, yeah. I think we need a bool to confirm the given right, I think, but I'm so not sure. Just bought C++ A Beginner's Guide by Herbert Stitt. Let's go, dude.
Yo.
Goated book, bro. Goated book. Type shit, dude. Ah, dude, my leg's fucking itchy as fuck, dude. Append. God, how do you slice again? I always forget how to slice in Python. Yeah. Holy shit, dude. 1 2 1 3. We make it a set instead though here, bro, low key. Or is that a pen? Oh my god, dude, I'm appending it twice here. That's why. Maybe. I think just as someone explained earlier to my CPP question, if you are good at the skill, your CV presentation is just a formality and matters a little, I think. That is true, Nikata, that is true. Okay, what am I getting here? I'm putting in duplicates, so maybe we do need a set here. Use a set. It's not gonna like it. I'm gonna have to hashable list. Oh, you can't hash arrays, dude. Shit. Yeah, that's right.
Why do you want to hash the array? Wait, what are you trying to do?
Because I was using a set, because like right now I'm duplicating all the values. Trying to think of a way that I can remove duplicates, and I just thought of a set. But I'm trying to think here how I can remove this shit.
Bro, Loki, I think if we went with the other solution again, it'd be easier.
Yeah, probably. I'm so close, bro. I just don't know what the fuck is wrong here, bro. Like, oh my god, dude.
Are you passing in your result, or no? You don't need to in Python, I guess. Right?
No, I'm leaving it out here. Passing it to 0, I pass in the path, right? We append the path in the beginning. We get our shitty one here. From J in range, starting at I, right? So we start at 0. We get our length nums. Path.append nums I. Then we backtrack to the next value, and then we pop to get our next value here. And we'll get the value that's. I need some way of checking if it's inside a res. I fucking don't know how to do.
So like, what is path? Isn't that what your path is doing?
Path is like, yeah, the list here that I'm appending to res. My you can see I'm getting the answer. I'm just not getting I'm getting duplicates, dude, and it must not contain duplicate sets, but I don't know. I don't know off the top of my head how to handle that, to be honest. Dude, I don't want to ask GPT, dude. Fuck. Oh, bro, fuck.
Wait, so why are you doing res append outside of the loop? Or I guess that makes sense. Because that's the current. Wait, so what does path bracket colon bracket mean? Like, what does that mean?
Fucking slicing, dude. I guess we probably don't even need to slice. We probably just add path.
Yeah, I think you just add path.
Oh,
Something's wrong.
maybe we do need to slice it. Why can't we add path?
No, I don't think you need to slice it. Why would you need to slice it? Oh, wait. So you're iterating through, right? With J, but you're indexing with I. I think that's the issue.
But I is a start where I'm looking at.
Well, I'm saying that like on lines 10 and 11, you're also using I instead of J.
Oh, shit, dude.
That's probably the issue.
Oh my god.
Yeah, there we go. All right.
Dave Cambo, day 175. Yes, sir, bro. 175, bro. Damn. I don't know. Let's see that. Yeah, I think dot copy can work here too. I think that, right? I think. Do it on Python too. Yeah. Okay. Anyway, what was your solution? The same way, right? One
Same
day
way
you-
as like the
you
one
will
that we
get a
did
job,
last
But
time.
if you quit now, but if you quit now, I hope day 180 you will get a job. It probably won't be anytime soon, bro. But I'm literally gonna start applying for jobs like probably like a week or two. So yeah,
Okay.
crazy grind.
If-
Appreciate it, dude. Thank you.
If you switch the language to C++, I can show you like the way we can use the old solution on this problem.
Let's see.
This might help you understand it better, because honestly, I think that the bit manipulation solution is like cooler, I guess. So obviously, like you need your result vector, like vector of vectors.
Okay. So what? Define it or
Yeah,
like a vector of vectors?
yeah, vector of ints, because that's our result.
Vector. Dude, I didn't even know how you would even do that.
Well, look, it's in the return type. It's
Oh,
in the
shit.
return type. Of the
Okay.
function.
Vector int. What you set a result? Is that what you were saying?
Yeah, I mean, that's what you call it? I mean, you can call it whatever you want.
Yeah, res. I
Res
was just
result.
Trying to make sure.
And then like define your in equals num size.
Brought it back. Ranch snack wrap. Spicy snack wrap. You broke the internet. Put a snack.
In coding interviews, do you have to use C++ for time complexity or no? I think it just depends on where you. I think that depends on where you interview. Is LeetCode your primary source of studying? I mean, no. I work on projects and stuff too. I work on LeetCode. I only stream LeetCode right now, but I plan on streaming some of my project work. But yeah.
Yeah, Max spends a lot of time outside of LeetCode, like studying C++ and things like that.
I was
helping him.
I was literally studying C++ for like probably most of the day. But anyway. Okay.
So,
sorry.
so you have your result, like where we're gonna place the subsets, and then you have your in, right, just the size. So then now we're gonna do the whole double for loop thing, but we want to include the empty subset this time, right? So you can start like I at 0.
I is less than. Are we doing the same thing? Where we're doing the.
Yeah, like
this?
1 to the power of 2 to the power of n, 1 shifted over n times.
1 to the power of n.
2 to the power of n.
Oh yeah, 2 to the power of n. Yeah. I plus plus. Right.
Okay. So like again, let's just think about like what we're doing here, right? Like just in terms of, because like I feel like once you fully understand it, it'll be like a cool insight, because like let's say that n is equal to 8, right? Or no, let's be simpler about things. Let's say that n is equal to 4.
Yeah.
Okay.
Yeah.
So what is 2 to the power of 4? Just
16.
16, right?
Yeah.
So what we're gonna do is 0. So I is gonna go from like 0 to 15, right?
Yeah.
And if you think about it, every number from 0 to 15 has a unique binary signature,
Okay. Yeah.
right? So we have like 0, 1, and then 1, 0 for 2,
Yeah.
and then 1, 1, and so on and so forth. So each one of those it's really going to be like, it's not directly indexing into our array, but it's like what's called a bit mask, right? So this outer number is going to basically decide what we include in the current subset in the inner for loop. Okay.
Yeah.
So you want to create like another vector here for the subset.
What do you want to call it? Like.
Subset. And then now you just want to do a normal for loop, right? Just like in j equals 0, while j is less than in j plus plus.
Yeah.
Right. So then now this is like where the, I guess, like quote unquote weird manipulation comes in. But like if you think about it, like let's just pretend that we have the binary number 5. So like let's say that I is equal to 5. Okay. So
Yeah.
the binary representation of 5, if I just go up to 3 digits, is 1, 0, 1.
Yeah.
So that means that we're going to include nums at the first index or the 0th index, right? And then nums at the 3rd index or like the second actual index, right?
Yeah.
Does that make sense so far?
I think so, but can you just jump on Discord and do that visual explanation again? I learn better
Yeah.
than just fucking listening.
Yeah, just talking about it. No, that makes sense. So
Shit.
like I'll just do like an example here. So if like n is equal to 5, right? Then our binary representation is 1, 0, 1. I'm just gonna say, or I'll put the leading 0. Why not? So then, okay. While we're going through our inner for loop, that's what's actually indexing into our array because it's going from 0 to size or in this case, right? And I'm just gonna also, this should be I, not, where's my brush? Oh, I'm on black. That's what, okay. So I is 5 in this loop iteration, right? And that's equal to this binary number here.
Mm-hmm.
And then in our inner for loop, we're going from 0 to in. That's like our J value, right? And then what we're going to do now is we're going to compare this J value and see if the bit is set in our mask up here, okay? So what values could J be equal to if we wanted it to be like exactly this or exactly this?
1.
So the trick also, if you notice, is we're going to do 1 shifted over by J. Why do we do this, right? Because if J is equal to 0, right, and we shift 1 over 0 amounts, right, like 0 times, it's going to continue to be, it would really be like the value of J, right? Or it'd be 1, right, in this case. So 1 shifted over by 0 is 1. So what we're going to do is we're going to use the AND operator on our current mask up here. So 1, 0, 1, 0, right? And in this case, this is going to be like this. So as you can see, these two right here are the same. So this is how we're basically checking, like, is the current iteration of J, should it be included in this subset? The answer for this one is yes, right? But let's say that J was equal to 1 at this point. Then if we shifted 1 over by 1, that would become 2. So then we would have 0, 1, 0. And you can see that that is not in our mask here.
Yeah. Okay.
And then, you know, whenever it goes on to the next value, 3, for example, it would align with this one, right? So then that's how we can kind of extract different subsets out of the number. Does that make sense? Or did I not explain it very well?
No, I think you did. I just think it's like I don't want to say I understand it because I feel like, you know, I don't in a way, but like I kind of get what you're saying, but I'm still kind of struggling, if you know what I'm trying to say. So maybe you could go through it one more time, but like a little slower.
Yeah,
but I
sure.
also think it's getting late too, and I'm getting sleepy, so I think that's probably playing a factor to it too. So I don't know.
Yeah, I mean, that makes perfect sense. I'll just do, like, again, another really easy example. We'll just do 1, 2, 3.
Yeah.
Okay. So our n is equal to 3 here, right?
Yeah.
And then we're going to have our outer loop go from 0 to 1 shifted over, or I'll just do like n to the power, or 2 to the power of n, just to be clear, right? So that's what I is going to equal. And then j will equal, I guess it would really be like this. J would equal the range of like 0, I guess I could type it like this also, to n.
Yeah.
Right. So that's like the difference. So what we're doing here is like, let's say, so first of all, right, whenever I is equal to 0, like we're just going to get our empty set, right? Because if like 0 and anything but 0 is not going to like evaluate to be true, right?
Yeah.
So like if like we have 0, 0, 0 in this case, and j is equal to anything, right? Like, first of all, if j was equal to 0, then this would technically work. And that would add our first element to the array. But that's why we're doing like the 1 shifted over by j. So our lowest value for this thing that we're comparing i's mask against is 1.
Okay.
Because again, 1 shifted over by 0 is still 1. Right? So if we add these values together, it's not going to evaluate as false. It's not going to evaluate as true, right? So, and that's going to happen for every single number in the first iteration while I is equal to 0. And then as soon as I becomes 1, right? So if I do 0, 0, 1, then when we're going through j here, the only element that 1 shifted over by will like correspond to is 0. Right? Because 1 shifted over by 0 is still 1. So that's going to correspond to this right here. And then since j is actually 0, we're going to use that to index into the actual subset.
Okay. Yeah.
And then whenever whenever I becomes 2, right? It looks like this. And then whenever j is equal to 1, then 1 shifted over by 1 is 2. And 2 again is this number. So then we would get the second element in the array.
Yeah.
And then whenever it's equal to 3, like this, whenever I is 3, we'll get both the first and the second index into the array.
Yeah.
Because then 1 shifted over by 0 and 1 shifted over by 1 are both valid here.
Yeah, bro. There's a reason why people hate fucking bit manipulation.
Yeah, it can be kind of hard to wrap your head around. You know, it took a lot of practice, obviously, to like understand this, but it's I would say it's very valuable. I don't know. It's honestly probably less valuable.
I think it is. Like, it's just so hard. It's so much like more simple, I guess, to wrap your head around a backtracking. Obviously, it took me a long time to wrap my head around backtracking, bro. I couldn't fucking do anything in the beginning, but like, yeah. I guess I just don't have a lot of experience with bit manipulation, and I just have to keep doing problems like that to be able to understand and get the tricks better. But I don't know. I do like. I am understanding it to a degree, but it's not like fully clicking for me. Like, and there could be a bunch of factors. But anyway, some guy said in chat, I wish I had a friend like Ethan. I am very lucky, and I do appreciate it a lot. Which language do you use for DSA part? Both, dude. C++ and Python, usually. Yeah, fuck.
Here, did you want to try to finish the problem so maybe you could see it, or because you're almost done with this one? Yeah. Okay, so let me make your share screen full screen. Okay, so what you're gonna want to do now is like also like what you could do maybe to like make things make more sense is instead of calling it I on the outside, you could just name it mask or something like that, like something more obvious. So like that's our bit mask for the current subset.
Yeah. Okay.
And then you could change that to be I on the inner for loop if you really wanted to. So then now we're going to do like the same if check that we were doing. So like if our outer number, right, our mask, and well, so you want to do mask first.
Oh shit, mask. Sorry, I'm getting confused with I and mask. My bad. Okay.
And then right, and then in parentheses 1 shifted over by I. Like if this evaluates to be a truthy statement, then you want to push back like the subset into the number into the subset. Right. You want like subset
Vector.
up. Pushback.
Whoops, not vector. Subset. The pushback. What?
And then-
nums I.
Yeah, because because like we only want to add numbers using I if the binary representation of mask contains 2 to the power of I. That's kind of the whole trick here.
Yeah. Okay. I think what I'm gonna have to do tomorrow is I'm gonna have to probably sit down and like spend like 20 minutes of my own time when I'm a little bit more fresh and really try and think about it. But I think I will get it. So
Yeah, I think you
I'm
got
gonna
it.
leave. I'm gonna leave this open for tomorrow, but I'll take a look at it when I wake up in the morning. But
Okay.
we just want to return our vector here, right? All right, our subset.
Yeah, we'll return result, really.
Oh shit! Yeah, result. Whoops.
And then on the right there, click enter, and you just want to push back the subset to the result. Semicolon. Well, mine's 16 too.
Shit pissed me off. Thank you though for that, dude. I really did enjoy that, so thank you.
Yeah, for sure. It's kind of it's
I
like
gotta
an
get-
elegant version, I guess.
Yeah, I gotta get my bit manipulation intuition better. But anyway, I'm gonna end the stream, guys. Thank you guys for watching. I will see you guys tomorrow.